finished the lecture series of ELLIS in May. It's a great pleasure for me to introduce Iryna Gurevych from the TU Darmstadt, close by. She is a professor there for computer science, and she is also an adjunct professor at both in Abu Dhabi and Sofia. She finished her PhD in Duisburg-Essen in 2003, and her research focus is on information extraction, semantic text processing, and machine learning and NLP to social science and humanities. She got a lot of prizes, for example, recently an ERC Advanced Grant as well as an ACL Fellowship Award. She is member of the Berlin-Brandenburg Academy of Science and Humanities. She's the first recipient of the Spitzenprofessur in Hessen. I'm not completely sure what that is, but it sounds great. And last but not least, she's the past president of the Association for Computational Linguistics. Okay, so welcome everybody. Welcome Iryna for being here. Thanks a lot. And
thank you. Yeah, good morning everybody. I'm delighted to be here. Thanks for the nice introduction. Today I'm going to talk about elevating NLP to cross-document level. I actually did not know quite what to expect, so I understand there are people from different fields of machine learning and AI. So that's why I decided to focus the talk maybe on something that relates to many people in the audience and not just like technical NLP stuff. So this is basically around the recent ERC Advanced Grant. So I've started this like a year ago, but I've been working on these ideas for some time now. And obviously we also have a lot of work ahead of us, and we are building kind of a new research community around this cross-document NLP with very interesting applications. We have 2 case study, peer review, and misinformation detection. And I would very much welcome if people from other communities and also from NLP would be interested to join. So that's why it's not a very, very technical talk. It's more like an advertising talk, hoping to get as many people involved in this very interesting research area as possible. And also, there's been a very recent Darkstuhl seminar on this topic in February. And I hope next week we are releasing a super substantial survey on NLP assistance in peer review. So that has been a collaborative effort in that seminar. So if any of you are interested, I don't yet have a link in my talk, but stay tuned. So it should be out next week, and it can give a very good single point of entry to those who want to join these research efforts. So to start with, of course, we all know that a lot of work nowadays is based on text. And this is true for an increasingly growing area of human life. For example, business, education, and also in research. Actually, we spend a lot of time working with text. So if you have ever coordinated a grant proposal with 20 PIs or even have written a paper, for sure, many of you, like with 5 people, it's already enough. You will understand what I know, So you receive comments from all sides, and you have multiple drafts of the paper, and at some point, so you get a headache, and it's a mess, and so this is what it is about. And why is it so? Because humans are bad at processing a lot of text, and humans are particularly bad at processing long text. I mean, large language models are also not good at that. They are getting increasingly better, but like if we think about NLP, and that was like a basic argumentation in the ERC grant for a very long time, it has been focused on short text classification, but when it comes to longer documents, And if you look at existing data sets, which is why a lot of work we do now is targeted at creating large-scale data for this cross-document task. So it's very hard, and we only have very few of those, and they may be also not of the best quality and forget about different languages. Just because in order to draw relations between text, you really need to read long text, and it's a lot of work, so it's a huge cognitive load. And humans are not good at that. It's even hard to find student assistants who want to engage in this task for money. And in recent decades in NLP, many things have got much easier, of course, because we excel at short text classification, so we can kind of support these long document processing tasks. We have good search, we have good recommenders, and information extraction, and also machine translation works amazing. So most of my staff in the lab do not speak any German, and they machine translate everything, and it's just amazing. So you can work in a German-based environment with documents without knowing the language. And of course, like the recent rise of large language models and all these things. So we all know about this. So many things are already amazing. However, these long document scenarios still remain a big open challenge. So as I said, we have two case studies. One of them is misinformation detection. I also have a separate talk on that, but I do not cover it today. It's a separate story. But there you basically need to evaluate multiple documents in order to kind of make inference over specific statements and make up your mind if you believe it or not, and so on. So this is very, very hard, and it's actually like an expert task. Fact checkers need to be specifically trained for a long time in order to approach this task. And then there's the issue of quality control. So in general, if you think like COVID-19 and also large language models is another viral topic, so people put out a lot of content about this, and a lot of content is not trustworthy, right? So if you read an article on an archive and you don't know the institution or the authors, it's extremely hard to evaluate this information. And this information cannot be trusted, but there are almost no tools in order to support this quality assessment process. And then if you think about this collaborative writing, so I think this example speaks to all of the audience. Writing a paper with 10 co-authors or a proposal grant, a lot of this work is still done on paper or on digital paper, but there is very little intelligence that will help the author to see if the comment has been resolved sufficiently, for example. So you need to check everything manually. So why is it so? When we think about a lot of text, we tend maybe to think about a long book, like a long text, or just a collection of documents. So this is true. This is static text. However, in reality, we deal not only with a collection of documents or one long text, but these texts are kind of living objects. They are subject to continuous revisions. So you need to trace the history of the document over time, and also you need to evaluate the document in the context of other documents. So this we call text in context. For example, you need to compare the comments or the review with the paper draft and reason over this. So you need to involve additional documents, and humans are very bad at doing this because it's cognitively a difficult task. So this is why we kind of have proposed this idea that we should treat text as a living object in context. And there is like one theoretical work package that we have in the project, and it talks about intertextuality theories. I'm not covering this in detail today. Just to give you an idea, evaluating text in context over time is conceptually, of course, not new. And the history is very old. Actually, it goes back to religious studies of Bible and similar religious texts. And in literary sciences, people have elaborated theories of intertextuality. That is how different documents can relate to each other in context and time. And basically, we use those theories in order to inspire a cross-document representation that we are going to use in this project. And why is this important? It is important because we want to generalize over different domains and text genres. So we want to develop techniques that are based on the same conceptual model. And of course, if we use these theoretical models, we have a higher chance of generalization because people have been thinking about them for hundreds of years. And if we can scale this to different types of text, then the models can more easily generalize. So that's our assumption. And we are particularly interested in those fine-grained cross-document relations, of which some have been studied in a limited context in NLP. For example, the NLP part of the audience may be familiar with the field of cross-document concept co-reference, cross-document event co-reference, so there has been some research on that. However, as I said, typically the data sets would be quite small given the large trend to big data right now, and also these are individual tasks. Also, we have research on multi-hop question answering, for example, but very few data sets. So our vision is that here we can produce approaches that will be enabling to studying these cross-document fine-grained relations in a big variety. So similar to text classification, where we now can adapt quite easily to new classification tasks. And that would, of course, open kind of like tons of applications in various domains, because evaluating long documents in context is something that people urgently need, especially in expert areas. So think about the medical applications where you have patient history and guidelines for treating diseases and maybe scientific literature. You want to relate a particular case to these different documents. Similar ideas apply in the legal domain, and also even in the software engineering. This has been a suggestion from the audience where I've given this talk. People deal with multiple documents, like comments, bug reports, some information on the internet. So it's a quite pervasive scenario. So this is this InterText project. As I said, the core is the ERC grant, but there are also some other projects which are funded by other sources, and they work jointly towards this vision. And if you have interest in this, we have a website, and there we actually put a lot of effort to collect all these resources I'm talking about. And also, if you're interested in more technical publications about this cross-document NLP, so you can find all that there. And today I've decided that it would be a good opportunity to talk about peer review. Why is it so? As I said, I don't know exactly the disciplinary profiles of the people in the audience, and what I know is this is a research audience, so everybody has to deal with this nasty peer review, be it in scientific publication or grant proposal evaluation and so on. So it kind of relates to everybody, and here we deal with scientific documents. We have chosen them as a case study because, as you know, scientific documents are very long, and now there is a big trend. They become longer and longer because the publication is zero cost, everything is digital. And there are references, there are different versions of the drafts, and there are, in my opinion, many great applications. And if you're interested in that point, as I said, there will be this big survey forthcoming next week. And this is quite ideal for us because this domain has everything to showcase this cross-document processing. We also have turn-based text discussions. So think of rebuttal discussions, for example. So there's also dialogue-like discourse, and there are edits, and there are also closed environments where all of this is collected. For example, systems like OpenReview have various types of data associated to one scientific manuscript. And last point, and I'm quite confident there's a broad agreement on this. We need AI-based help to deal with this complete information overload and system killing itself, where people are starting to use large language models to produce content, but never read the content because it's just too much. So this area is undergoing quite big transformation now, and I think that we need technologists in order to provide novel tools how to cope with this information overload at a never seen before scale. And here in this domain, we want to propose new tasks, data and methods for NLP-based support in peer review. So what I'm going to talk about in the rest of the talk are two things, data and tasks that we have initially proposed, and also two selected papers in the domain of text generation, just to give you some examples of things we have been working on in the domain. So let's start with the data sets. Getting the data in NLP is, and AI is in general, is increasingly difficult. We have to deal with all these additional issues that we did not have before, like ethics, licensing, GDPR. So in my group, I think every third submission needs ethical clearance in the meanwhile. Maybe it's growing even to every second. Because AI has huge ethical implications for the society and dual use implications, and also GDPR is now a big concern. And if we want to publish something in our disciplinary venue, very often we have this experience that the publication requires clearance, and there are ethics committees and they will flag it, and yeah, we need to work out these issues. And it's already very difficult if we have one source, one group of authors, and establish genres with clear rules. But now if we move into the direction of cross documents, it becomes a gray zone, and it becomes extremely tricky because we have now different document types. We have attribution and personal data, and we have maybe partially confidential documents like peer reviews in the NLP domain. So we need also to put a lot of thinking in order how to design the data collection side of things. And the community basically follows three paradigms. So one paradigm, and this is an obligatory question I get in every talk. So there's open review, just go and take the data. So this is a wishful thinking. So the German GDPR bans all these things. You know, people have published the data, but it does not mean that, or does not imply you may use it for training AI models. So this approach is actually illegal. So second approach is we look for open sources, and this is something we really do. I will show an example. It's quite easy. However, well, we depend on these sources, and they might limit our study in various respects. For example, they are limited to particular domains or particular document types, or maybe also of bad quality. And the third approach, and here we have proposed a novel way how to collect data, is data donation. And this applies to any source, so we can ask people to donate their data from any source, basically. So that works around the GDPR because people give us the consent for their data, but the downside, it's not that easy in practice, so a lot of work needs to be put in order to convince the people to give their data and all other considerations, so in the peer review domain specifically. And well, in our community, we have started this with the donation approach at the ACL rolling review. So the NLP part of audience, of course, know of this, and I hope all of you give your consent to donate the data to this data collection. And yeah, it took us a long time. So it was done before the ERC started because we had to consult different committees at ACL, and we had to consult lawyers to work out a good approach. So it's tricky because, for example, reviewers may give the consent to use their data, but it's not enough if the authors do not give the consent, since the review might leak some ideas from the data. So basically it's quite restricted, since we need the agreement from different parties who are stakeholder in this process. And first we ask the reviewers if they want to donate the data. If they do not want, then we stop the process. Then we ask the authors, and in the first version of this workflow published then, we waited for the paper to be accepted. So that was the verdict of the ethics committee, that we may not use any rejected papers because they may be subject to resubmission. However, in the Darmstadt seminar, we have rediscussed that, and now that this data donation is more established, people don't have as much anxiety, and they kind of allowed us to ask at any time. So not only after acceptance, because many people publish preprints anyway. So the content is not confidential. In a sense, the authors may decide it. And and we have a lot of consent forms, license templates, and also an open source implementation. So this can be applied potentially in other communities which are open review based, right? Because it's based on open review, and our idea in following this was that if we build it in open review, we can later scale to other communities, not only NLP. So this workflow, as I said, currently runs at ARR, and the good thing about it is that we want to continuously collect data. So the data set, though it's not extremely large, many people do not donate the data yet, but it's growing over time, so that's a good thing, and we don't put much effort in this continuous collection. And one of the big kind of issues with the first version was, as you see, uneven score distribution. So people tend to donate the data if they have high scores, and for the resulting uses of this technology, this data set is not very diverse, because we want to have kind of good and bad examples. And that was a major limitation. As I mentioned, in Darmstadt, we now have developed a new protocol that is less restrictive, and it's already implemented in ARR since this April, very recently. So we run this data collection on a much broader basis. And we, of course, very much welcome your contributions. So then, another way to collect the data, as I said, is we look for open sources on the web. So we have found this publication platform called F1000. And this is a collection of papers, revisions, and reviews in this open science domain. So there are different communities there and different domains which use this platform. And the papers are reviewed post-publication. So it's not common in our community, but in other communities they use it. So first they publish a draft, then people from the community would review this draft, and then those who publish the draft use this in order to improve their manuscript. So this is the idea behind it. And the good thing about this particular platform is that they have an open license, so CC BY type of license, that allows to use this for research purposes. So this is what we do. We extract this data. And yeah, so it's not very huge, but the good thing about this data set is it's diverse, okay? So we have different domains and different types of text. And this is complementary to our ARR-based data collection, which is very restricted in a sense that it all comes from one community and represents a specific type of research publications. And then based on this data, we propose some tasks and provide in the article last year annotations in order to train models. Our first task is linking. Given a document A that talks about document B, we want to find so-called anchors in document A and link them to targets in document B. Okay, so because we are interested in these cross-document relations. So there are two types of links. The first is explicit, like the first paragraph of section 3, and the second type is implicit. So for example, use of mosquito traps is an instance of an implicit link. And here we can envisage different types of training, for example, based on weak supervision, where we first collect these explicit links, train models, and then try to identify implicit links, for example. And this task might sound familiar because there are isolated works who have previously worked on, for example, citation, span detection, plagiarism detection, and evidence detection and fact-checking. And basically what we propose here as linking is a generalization over these tasks. So I mentioned we have this general cross-document representation, so we can generalize over different tasks. So our second task is versioning. In versioning, we are given two revisions, A1 and A2, and we want to find edits between them and link them. And in future work, or actually not quite future, I hope it will be accepted at ACL and published soon, so this is what I assume. We'll link this to edit summaries, for example, like authors provide a summary, what they have changed in a rebuttal letter, and we can trace it down to the edits, for example, to make the evaluation of sufficiency of changes easier. And some of these tasks are familiar from related work in Wikipedia edit analysis, which has been in existence for a long time, and also from student essay revisions. So versioning is a general form of these tasks. And in our work, in this particular work, we bring this to the scientific domain. So we have built a huge corpus, so this is this ACL work, which I think will be accepted. It had very good evaluation over different domains based on the data sets that I've shown, and we can classify these edit intents. And scientific revisions are particularly challenging because these are long texts, right? So one comment may relate to different edits, so it's quite like a big task to find these edit changes at the right level of granularity. But it works quite well in this work, and we distinguish between two kinds of revision. The short scope revisions, which are minor edits, especially it is just one intention like a paraphrase, or the long scope revisions, which are major edits and which are dominating in the scientific domain, and usually they incorporate many complex intentions. So the extreme case would be a complete document rewrite, right? So the document is heavily rewritten, or some parts of it are rewritten. And so far, this scenario has not been studied, according to my knowledge, at all with these long scope revisions, and we are the first to do it. And it is very important in many real-world scenarios, for example, business documents that may be very substantially revised. And finally, the last task is the pragmatic tagging task. So that is easier conceptually because a peer review has particular job. So that's why it's related to pragmatics. And this is about labeling sentences in the review with pragmatic tags. For example, recap, weakness, strength, to do, other, and structure, so that can facilitate further processing of reviews, for example, summarizing the reviews, or it can facilitate revising the document by extracting automatic to-do lists for the documents to be revised and so on. And there has been a recent shared task called low resource multi-domain pragmatic tagging of peer reviews that we have proposed, and this data set is also available. So we have done a couple of studies based on this data. I don't go into details, just to give a rough idea. A lot of questions can be studied if we can identify these links, revisions, and pragmatic functions of sentences in review. So we can answer questions: what is the intention of sentence? What is it about? What changes did it cause in original manuscript? What parts of paper received most criticism, or which type of comments trigger most change? Or ideally, I can imagine very useful for PhD students: which changes do I have to make in order to get my paper accepted? So this is a kind of joke, but this is the dual use concern that we discuss in our ethics application. Of course, this technology sounds very good, but there are also big concerns. So what kind of impact it can have on a younger generation of students who get used to this technology support. Right, so the next major resource we have proposed is NLPeer. So basically here the idea is to combine openly available and donation-based datasets from our workflow in a single benchmark. So you only have to use one benchmark instead of using separate datasets. So it's a massive resource which covers 5,000 papers, 11,000 peer reviews. And the data is ethically sourced, so you can use it, and you don't even have to write your own ethics application, because we already have clearance for all this work. And this is coupled with several reviewing assistance tasks, some of which make use of cross-document relations, but others do not, like, for example, scope prediction or pragmatic tagging. And this is a foundational resource for both intertextual NLP and NLP in peer review. So this work has been published last year at ACL, and the data is freely available. So to be more specific, in this NLP resource, we collected 2 entirely new corpora from the CL domain, and also we added this F1000 resource, which makes it very useful in various respects. For example, because we have papers from various disciplines, we have papers from different time periods, and also different additional metadata available, like, for example, peer reviews. And in that paper, we investigate several tasks which can specifically assist junior reviewers. So as you know, this is a growing concern in machine learning related fields, that the population of reviewers is extremely junior, right? So students, even in the first year of PhD, who have never published in a main venue, are asked to review papers. So in ARR, they kind of now have mandatory, you need 3 ACL publications, but it's not going to really work, because, you know, senior people will ask students to review. It's impossible. I mean, I cannot review 50 papers for my lab. So I think that we should take a different approach. We should train young people to review. Why should we do this? And why is this not a waste of time? Because reviewing is mainly about argumentation skills. So this is what students have to learn, and this is what junior students often struggle with. And I work a lot also with educational researchers, and they say, if I can peer review the work by others, I learn argumentation skills which are critical to my own research. That is, I write better papers. And this is why I think it makes more sense to start this reviewer education very early by providing some scaffolding, teaching people how to review, how to answer questions, for example, if the paper has enough substance, right? So, and our data can help with this, and we have 3 different tasks, and I'm just going to look into one of them, guided skimming for peer review. In this scenario, we can help a junior reviewer during their multiple repeated reading of the paper, and we can highlight specific regions in the paper that require the highest attention. Okay, so where to focus reviewing attention. And how to do this? We first extract explicit links from the reviews. You remember we have these reviews and papers, and the explicit links are like in figure number 3, you do something, right? So we extract these explicit links from the reviews, and then we anchor paragraphs of those links, and we consider those paragraphs which are explicitly referred to from the review as being relevant or review worthy. Okay, so it's kind of distance supervision inspired approach, and we use these binary labels during training and evaluation. For this, we train quite a simple SciBERT model, so BERT for scientific text specifically, by sampling relevant and irrelevant paragraphs of the paper and fine-tuning the model with the help of contrastive examples, so we know which paragraphs are important and we kind of learn their properties. And the resulting model is a regression model that predicts the relevance of each paragraph in a paper, and then we can rank these paragraphs accordingly and highlight the top-ranked ones as the ones that require particular attention during peer review. And we have applied this model to unseen papers, and we generated this relevance ranking. And we used again the same procedure, that those that have explicit references in the review are relevant, and we evaluated this model in the graph on the ACL 2017 data using precision and recall at K as metrics, and we can see that this SciBERT model performs significantly beyond the random baseline, so this approach seems to make sense, and it shows that we can predict the linked passages of the paper, and also it can be interpreted in such a way that the targets of explicit links in the reviews can serve as an interesting signal that correlates with certain linguistic features of the paper. All right, so now I move to these two examples of text generation. You know that the generative AI, generative NLP are areas which are particularly growing nowadays, and we have two works in the scientific domain, again, to assist authors, specifically junior authors. So this is, by the way, if you want to publish, very good training, very good framing for this research to counteract on ethical concerns, right? So in an ethics application, you always have these questions: what are the potential benefits and what are the potential harms? And you need to argue that the potential benefits are much higher than the potential harm, right? And one thing which is argument which I believe is widely accepted, if we train a large number of junior reviewers, so it's going to be a very big benefit. So being more weight than the potential harm of misleading reviewers or biases or whatever, right? And that's why a lot of papers from our lab are framed as assisting junior reviewers. And I mean, it's not like fake. I mean, these tools can be particularly useful in this scenario. So here we have two tasks which we consider to be difficult in my experience for young researchers. First is to write rebuttals, and this is increasingly popular in machine learning related fields and now in NLP, and students struggle a lot with this task. And the second is to write a related work section. So the first work is on rebuttal generation. So rebuttal is a key component of the peer review, and the goal of the rebuttal, like, is a pragmatic one. We want to convince the reviewers of the quality of their work, and also we want to correct potential misconceptions. And writing rebuttals is very hard, usually, because it's already hard for young people to recognize an argument behind a specific passage in review. Sometimes it's vague, right? So reviews may also have not so good quality. There are all kinds of issues around that. So in any case, we need to recognize the issue addressed in the review, and then the reviewer, the junior author needs to kind of think of a good counter argument, so how to counter this criticism. And this is particularly hard for very subjective evaluations of the paper, where reviewers' background and also general views may play an important role. So reviewers have some preset attitudes, okay, so what the paper should be, and now the question is how to choose the best argument in order to counter that particular reviewer criticism. And in this work, we are inspired by some other work that I had with cognitive psychologists in a project on anti-vaccination and how to convince people to accept vaccination. And they call this approach jiu-jitsu argumentation. So jiu-jitsu is a type of sport where you can use the opponent's strength in order to defeat them rather than using your own strength, right? So, and I have one example just to make it more clear. It's taken from this anti-vaccination work. So here, the tweet says, in the end, more children will die from the side effects of the pandemic than from the virus. And in this jiu-jitsu argumentation paradigm, we first identify the underlying attitude root. So this is a kind of psychology-inspired classification. They have such attitude roots. So here it's fears. So the person who is making the statement has some fear. That's why the statement that the person is opposing the vaccination, and in particular, so the theme of this fear. So fear may refer to different themes, and here it's the side effect. So now, to formulate a canonical rebuttal to this type of argument, which may be quite expressed in different linguistic terms on the surface, but always has this kind of underlying attitude root and theme, fears and side effects. So the psychologists would acknowledge the concern, so it is a valid concern, and there is a risk of side effect with vaccination, though the vast majority of these are minor, and they may also present some statistical evidence on that. And it is quite common to experience mild side effects like fever and fatigue in any vaccination. However, and here comes this jiu-jitsu strategy, so if no vaccination is taking place, then many more people will die, right? And then they will present basically evidence that the number of deaths for people not vaccinated is much higher than the number of deaths related to side effects. So the trick here, the rhetorical figure here, yes, we acknowledge your concern, and then we use the same attitude root, so the person has fear, but the other theme, death, is even stronger, in order to kind of motivate the person to reconsider their view. So this is the psychological trick. So we basically take this idea and we transfer this technique to the case of rebuttal generation in scientific publishing. And based on this strategy, we develop a new data set, which we call JITSU-Peer. And the data set has over 2,000 reviews annotated with attitude roots and themes, along with 300 canonical rebuttals. So we kind of reduce all the space of possible rebuttals and concern to these 300 cases of combinations of attitude root and theme. And reviews within the same attitude root theme cluster can now be addressed with using the corresponding canonical rebuttal, and canonical rebuttals also have different rebuttal actions. For example, mitigate criticism, so that in different contexts we can use different types of or different variants of the same canonical rebuttal. And in developing this work, we propose 3 downstream tasks in order to assist junior reviewers along with different baseline models for these tasks. So the data set we created is made in several steps. So I just reduce it to 3 main steps here. So given a review with multiple sentences, so these are these statements there, we first identify attitude root for each review sentence. And here we use the ACL peer review aspects as the attitude roots. So something like clarity or substance, right? So it's an analogy from vaccination now in the peer review domain. These are review aspects. And then in step 2, we enrich the identified attitude root with a theme, and we use the review paper section link here from another available external corpus where review sentences are linked to particular sections. So we use these sections as our themes. For example, the review sentence talks about the theme overall writing of the paper. And finally, we generate descriptions for each attitude root theme cluster. So we describe the combination of each attitude root with a theme, and then we retrieve the best canonical rebuttal for that cluster using preference learning. And in order to apply this preference learning, we basically construct a preference learning data set where we present particular concern and a set of responses and ask which one is the best and which one is the worst, and from this we can construct preference training data. One of the tasks that we have proposed in this work is the novel task of canonical rebuttal generation. The task involves generating a canonical rebuttal when we are given a review statement and a rebuttal action. And here we have experimented with different models, and we observed that all models reach a plateau after some training point, and they do not generalize very well. So we attribute this result to a big variety of potential rebuttals in our data set, which is difficult for the model to memorize, to choose the best rebuttal for each given test case. So here in this work, I think that the baseline results are not very high, so there's a big potential for better technology based on the data that we release. Now, the second study is on related work generation. So research should build upon prior knowledge, not always, but it should be the case that we know all the prior work for our topic, and the amount of prior knowledge is constantly growing due to the growing number of publications. So we would like to have some automatic support for related work analysis, which is actually a very difficult task, right? So a good related work is difficult to write. So what many NLP works have done so far, they formulated this as a summarization task. However, I am convinced this is not good formalization of this task, because good related work should understand the pros and cons. So it's an argumentative task and not a summarization task. And then it should kind of result in figuring out the gap, right? And the summary is not enough for that. So that's why we think that one can do a lot of interesting research in this space. And citation text generation aims to generate a passage of text based on information about the citing paper and the cited paper. So there are 2 papers involved here. So it's a cross-document scenario. And as I said, the task has been actually widely studied in NLP, but so far it lacked a unified task definition. So studies are conducted on isolated data sets with different task definitions, and there is, or before this work, there was not a common benchmark. So it's very hard to compare text generation systems, and this is what we want to improve with our work, and we propose a benchmark that we called SideBench. According to our knowledge, it's the first benchmark for citation text generation, where we unify several pre-existing data sets. So there's no new data, but we take the existing data and we kind of introduce a generic model on top, which makes the task definition uniform, and we develop a large number of baselines and evaluation metrics for this task. So just to give you some insight into main results, we applied also quite old methods from summarization, like text rank, lex rank, and the lead baseline. So lead selects first 3 sentences from the input. It just concatenates the initial sentences of the cited abstracts. And text rank and lex rank are very old methods, which are graph-based, unsupervised methods for extractive text summarization, where we just use existing implementations. And then in the middle of this table are abstractive baselines built with pre-trained language models. So at the time we had this lead model. Nowadays we of course have some follow-up models. So this is already 2 years old, I guess, and so we use this in 2 configurations, even 3 configurations: base, large, and specifically fine-tuned, pre-trained on archive papers. And finally, we experiment with supervised models that are fine-tuned on a mixed training split from our benchmark. And we evaluate everything using 2 metrics, Rouge and BERT score. And what we can see in the results is that supervised models perform best, but extractive baselines also perform surprisingly well. And also it's quite interesting that the smaller lead-based model often performs on par with a large model for this task. And also we note that the 2 evaluation metrics, Rouge and BERT score, are highly correlated in this study. And so fine-tuned supervised models performed best in terms of their scores, but we also wanted to get qualitative insights. Are there some systematic qualitative differences between generated texts and original human written texts? So does it make sense to work on this? And since checking this manually would be too much effort, we used 2 discourse tagging models from previous work to predict citation type and intent. And then we compared the distributions between the generated texts and the human-based reference. And we have found that the generated texts follow a different discourse structure pattern. For example, in this figure, we can see that the baseline models on top generated a lot of reflection and other sentences, while under generative narrative citations and single paper summaries. However, supervised fine-tuned models generate those, and this is in line with the actual reference text from the test set, which you can see on the bottom. And overall, this project kind of enforced us to ask what kind of information is in fact needed in order to generate accurate citation text. And as I said, the common approach was to feed the model with abstracts and citing context, but it turns out that it is not enough, and the summary-based approach is not a good one for writing the related work section. And now we have some follow-up work under review that focus specifically on the question what type of information is needed in order to generate high-quality citation text. And of course, we are also experimenting with large language models on this task. Now, let me conclude this, just giving you some insight in our ongoing work. So one work we have is on cross-document implicit linking, where we link spans from one document to spans in another document. The challenges here are the subjectivity of links, and also we want to do it cross-domain, so links may be of different nature, and yeah, we have some experiments based on data-driven taxonomies and large language model-based retrieve and re-rank approaches on this task of cross-document implicit linking. So I work a lot in the scientific domain with Tom Hope. So he is from the University of Jerusalem, and he's also at LNAI, so we have some links to Semantic Scholar. And another work is quite of different nature. So here we look at temporal graphs for the science of science. So basically, we think of papers and paper citations as multi-party citation dialogue temporal graphs. So just imagine authors talk to each other through citations. So we convert basically a static text to such dialogue-like temporal representation. And we are interested to see what can we predict from who is talking to whom about what over time. And also, we're interested to predict future scientific dialogue. So what is going to happen in future? So what kind of follow-up work this work may lead to? Or, I mean, an interesting, intriguing question. So how to make the work impactful? So how can we predict the impact of work, or also maybe steer the impact of work based on the insights from this temporal graph analysis? Then we have a project on the novelty assessment. So here we want to extract novel claims from scientific work. So we want to know if the work is novel or not. And the main idea here is that we use peer reviews, which I've introduced a lot, and we identify statements that refer to the novelty of the scientific paper. We link this to the paper, and from this we try to learn the notion of novelty, where we can predict the novelty for unseen papers in future. Then last but not least, so I'm quite interested, I've talked little about this in assisted writing, so tools that help people write and revise text. And I think in the meanwhile, a lot of people have realized, so the community have realized machine and human have different strengths, and rather than seeing like large language models as fully automatic assistants in many scenarios, it makes task to have a human and machine collaborate. And here, so the idea is that, for example, imagine you're writing this related work. We do not fully delegate it to the machine, so please write related work for me, but we get an initial draft, and then human and AI agent collaborate on iteratively improving this draft. So that requires, for example, novel research, how to split the complex task of citation text generation in smaller tasks, and how to delegate these tasks to different parties. I mean, there's also all this hype around LLM agents. It's somehow also related to here, but the team can be composed of human and AI agent or multiple agents. To conclude or recap, so I've been starting this talk with this general vision of how to intertext, which is about cross-document NLP as the next major step. And I talked about text as a living object in context. And in the talk, I've used the peer review domain as one particularly good domain in order to study many of these foundational research questions. And we have different lines of research based on scientific cross-document text related to creating large data sets, scientific argumentation, scientific text generation, and science of science. So these are like separate lines of research in its own right. And we have proposed several data sets which can save you guys a lot of work if you want to join this research. And I've described two examples on rebuttal generation and related work generation, and also talked a bit about like what we are doing right now. And I invite you to kind of explore more, and I'm looking forward to any questions. Thank you.
Yeah, thank you very much, Iryna, for this very interesting talk with a very interesting theme, of course. Questions? Yes.
Thank you very much, Iryna.
Oh, wait a second. We need to have the microphone. So.
Okay. Thank you very much, Iryna, for an inspiring talk. I wonder, in some of your parts where you learn from a lot of examples, whether you advance then the skills or whether one tends towards a average performance. So, for example, when you do the ranking of these paragraphs, what should be important for reviewing? I mean, personally, as a reviewer, I would think I have a very complex function, yeah? So when you get the formalization wrong, then this is like the min function and it plunges down. When you do some argumentation, then it's sort of like an average, yeah? It's not, if there's a bad paragraph, which is not so a good argument, I don't care, but if the next paragraph remedies that. And I wonder whether you would, for example, steer the young scientists to the wrong direction if you just sort of like average over observations. And I think this is true also in some of the other parts. I think there are too many papers that just summarize the first 2 lines of the abstract of the other papers rather than, as you correctly said, say there must be some argument about what is done about them.
Yeah, great question. I have many things I can say about this. So first, I don't think one system will serve different target groups among reviewers because the workflow of an expert reviewer is different from a workflow of the junior reviewer. So let's start with this. You have your shortcuts, or you know how to find like important parts, right? So for you, such a tool may be even annoying, okay, because you are very experienced, so this experience just in your mind. For junior reviewers, they often don't know where to start, right? So I think this tool, the application, how to integrate it into the workflow is something that human-computer interaction people should look at more closely, because we usually, like in NLP, we work on NLP technology, but not on the product, on a human-facing system, and I think there are many research questions that need to be attended there. So next, in our ongoing work, we'll look at this human-AI collaboration exactly because of these reasons, because there might be tasks that are better suited for machine, and there are definitely tasks which are better suited for human. However, it depends on the properties of this human and this LLM model, right? And humans, so human is not equal human because we have background knowledge, and this person has one set of knowledge, the other set of knowledge, and the machine should actually also have some user model in order to, you know, make useful suggestions. And at the end, I think, like, you know, this question reminds me of my first steps as a researcher. I had my first DFG project on semantic information retrieval, and whenever I give a talk on this, especially in interdisciplinary audience, people from the pedagogical sciences would say that this technology is harmful for people because we de-learn to search for literature in the library. Okay? So now, I mean, it sounds funny, but something similar is happening. I think this information overload and LLM-generated papers, you name it, it's just there. So it's going to happen whether we want it or not. And I think we need to find new ways how to deal with this. And this NLP progress can provide some input to this, but how to make a useful product and how to teach people. You know, we also need to teach these young reviewers, similar to what we teach people when they use a search engine, that the result is not perfect, AI has biases and blah, 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 right? And then finally, so I did not want to cause a headache in my audience, but I have one PhD thesis of a student who gives feedback on feedback. Okay, so here it's even more complicated because I said training people to write peer review makes them better authors. So we actually not just have people write the peer review, but we have another level of intelligence, also human and automatic, that gives feedback on feedback, right? So it's not like we just let people use it, but we need to kind of come up with good ways how people can understand this is good feedback, this is bad feedback, and here AI made a stupid suggestion, and then human in the loop, I mark it as not being useful, and the model learns that this is not useful, right? So there are many things about this very valid point. I totally agree. So this is just not like has to be thought as a black box. I think there should be like big interdisciplinary collaboration with people, as I said, from related fields of machine learning. Specifically, human-computer interaction is extremely important in order to develop an idea of how to make a useful tool of the NLP technology.
Okay, I was actually debating a little bit whether I should ask my question because it's actually more or less the same that Steffen asked, but I'd like to take it from the pedagogical to the philosophy of science level. And I think your case study is perfect for showing also the limitations of what you can expect from using AI in a very, very good way. So, because I was actually, when you said there's probably consensus that we need AI-based help in this very complicated process, to a certain degree, I totally agree, but there's a certain danger, and I think it's already out there now. But let's take it now to the philosophy of science level, and I mean, my namesake, Thomas Kuhn, normal science. I think what we're kind of optimizing here is if we assume that everyone knows what the right framework is, we're improving things because we're climbing the hill where we think this is where we need to get. But imagine Albert Einstein was basically in this pre-relativistic domain. Would he succeeded? Probably not. Maybe this is just the situation things are. You have to really struggle against normal science hard enough to change the paradigm. But my worry in a way is that a number of young Albert Einsteins would just get too frustrated and leave science, right? So I think what you're having here, if you take it to the extreme, the perfect AIs would be able to actually do this whole game of doing conferences and reviewing on their own, right? And we could just stop doing it, and that can't be the way we develop insights. So there have to be limits to what you can get from defining writing papers as an empirical optimization task. There has to be something coming in, and I think for that reason it's extremely interesting to actually push it and see where. But I wonder a little bit, and that's my question now. Do you have any idea how one could maybe in our community have ways of also encouraging kind of people to kind of maybe look at the other hill where you have to go through a valley first in order to climb it, but it may have a higher peak and you just don't see it, because that's my worry, that not just the young researchers but also their kind of review kind of the people in their department would rather climb the hill where we are kind of getting a lot of papers done, and rather than risking to kind of go through this valley, and actually you won't survive going through the valley if everyone believes that this is the way to go. Okay, sorry for the long question.
Yeah, so I mean it's overlapping a bit with the previous question, but I think it's a community level question that I've been thinking about a lot as the recent ACL president, and also discussed this with many people. I personally think we should decrease the publication activities. But in order to do so, we need to change the incentive structures. For example, we need to change the evaluation. So the DFG has undertaken some shallow steps in this direction. So you may not report more than 5 papers in your CV, but at the end of the day, everyone is opening Google Scholar because people do not want to read any papers, even if they are only 5 or 2 or whatever. But I think unless we change the incentive, we have no chance to change the behavior of people, since people have to comply with the world due to different career pressure, funding pressure, whatever, right? And I think this is like a very fundamental community level issue, and the situation that now we have very high heterogeneity of the community with other countries or geographical continents with totally different work cultures, being major stakeholders, and industrial partners being also stakeholders with a completely different work structure, and having 200 people on a paper, right? So, I mean, we are undergoing a major transformation, right? And there is no easy or lazy answer to this question, because this is very deep at the root. So, apart from this philosophy, I mean, I have this discussion with my students continuously, because they just not reasonable in wanting to publish 3 papers, top-level papers every year, for example, right? And so when I started my career, I had to push my students to publish, right? But now my students stand on my feet. They want to publish. Why I do not allow publishing that much, right? So this whole game has fundamentally changed, and I understand that. And it's hard to argue against the whole world, right? So I can tell my students, I think this, right? But they see that the world out there is not following my heuristic. So yeah, at the end of the day, you know, back to your question, original question, I think people using these tools, so Einstein, if they were born now, they will just learn to use these tools as part of their whatever workflow, intellectual workflow. And those who are able to use the tools effectively and combine it with their intellectual power, I think they will be more successful than people not using such tools. This is like as if you were not using search engine or Google, you know, this is the first thing I do, right? But I think that the humans still should have the agency in the scientific process, and the humans should be equipped with new skills, how to navigate this big space of low quality information. And here I do think that we can provide support, right? But that's why this project on human AI collaboration, because I think that the truth is somewhere around there. So how to make it work, right? And this opens new research questions. For example, how to split a complex task in smaller parts. What are those parts? Because it should be dynamic and it should be adapted to this expert user and their knowledge and the particular strengths of the cooperating actors, right? So in a multi-agent framework, basically. So what do students think?
If I can, I have one, but more interesting.
Yes, I have one question. One question. First of all, thank you for the talk. Very interesting. Not philosophical at all. It's more technical. Like I think on slide 27, you were talking about the jiu-jitsu technique, and I think this was the beginning of the process to then train the model and evaluate it. And so you did everything manually, like you found the team, it was defined manually, or I don't know, like semantic role labeling technique and something like that you think could be useful
So
in this
which
process?
part do you mean? Rebuttal or?
I think it was, yes, for the rebuttal.
So the themes, we have a corpus by external authors,
Okay.
and they link review sentences to paper section.
Yes.
So we take the title of the paper section as being the theme.
Okay. Okay.
So basically it's corpus based.
Okay.
So there's no intelligence involved here. We rely on the knowledge in this training corpus.
But then when you compute instead the rouge, so you go to the evaluation step, you also base this, I mean the ground truth is the review that you got from the
So this
from the
refers to
corpus.
citation text generation. So these are two different
Okay.
papers.
Okay. No, I mean, yes, it was like the slide next to the one of the team, so they are not related at all.
So 27, I
Yes.
just go back to this 27.
Yes. I
This
think-
one?
Yes, here we were talking about the jiu-jitsu argumentation. And so, from my understanding, this was from where you then built the corpus for this experiment.
You mean here? So this
Yes.
canonical rebuttal generation.
Yes. Are they related? Like then?
So basically the same evaluation measures like in the previous work, Rouge and Bird score. Yes, so that's correct. And you're asking what is the gold standard?
Yes.
Yeah, so we use some manually written rebuttals, basically as the human reference here.
Okay, but then my concern, like, it's because the rouge cannot be that tight if you take ground truth from different authors, no? Because at the end, how can you say the first in the first place their ground truth is the correct one, or maybe something written in a different way?
Yes, of course. I mean, these measures are not very well calibrated, as we all know.
Yes.
Bird score is more like on the level of semantic similarity, but you know, in NLG there are hundreds of metrics, and I think they can extend this work, but we have not focused on this
Okay,
question. Since NLG is not our main interest, we just use the inventory of existing metrics, but we know that they are not very ideal.
Okay. I thought it was more. There was more interest in that. Okay.
Yeah.
Thank you.
Maybe a quick follow-up question to this canonical rebuttal generation. Would you trust such canonical rebuttal generated texts on your own for
No.
long papers?
So I mentioned that this work did not result in a
Yeah.
strong performance. So I think, you know, here we need to work more on this. And one obvious issue is that the rebuttals that we get are quite generic. But I personally think in order to convince me, I want to have specific evidence, not just like going back to vaccination. It's a bit easier, right? If you don't do the vaccination, more people will die, but actually I would like to be presented some specific evidence, right? And I think one could extend it maybe by some retrieval augmented generation, by looking for some specific evidence for this particular case, because that's actually the limitation. You cannot have this generic evidence. It should always be related to the paper itself. And yeah, therefore I think this is like just to showcase the task and different steps involved. But the resulting system itself is not good enough, right? So more work has to be done, and I think it can be also useful, but with much more intelligence. And also this work is LLM, retrieval augmented generation. All these things came later, and I think this could be a very promising thing here. But it requires understanding the original paper, because the evidence needs to be targeted specifically at this context. Still, I think, by the way, that even the generic rebuttal may be helpful for junior reviewers, because very often they just don't have this kind of database in their mind that experienced people have, where they can just retrieve a specific rhetorical pattern. Basically, the generic rebuttal gives you the rhetorical pattern that you need to enrich by concrete evidence in the second step.
Well, it sounds a bit like, to me, that it's more like if if you go to a company with a complaint that you get a canonical rebuttal saying politely, we don't care.
Yeah, not necessarily. I mean, if it's a good canonical rebuttal, it shows the way how you can counter the argument, right? But as I said, the generic response is not enough. As a customer, you want to receive a response specific to your concern,
Exactly, yeah.
right? And this is something that this system did not cover at the time.
Yeah, this is what reminded me to this generic rebuttal from the company.
Yes, exactly. Because, I mean, in reality, so what do I teach students to do? They need to identify the type of the argument, and then they need to identify similar papers to their paper and see how those papers argue in order to construct this more specific rebuttal or retrieve the appropriate evidence. And I think that retrieval augmented generation can be very promising to support this step, but this is future work for anybody who wants to work on this.
Okay, further questions? If this is not the case, let's thank Iryna again for this interesting talk.